Hey guys, I wanted to make this video giving you guys a quick rundown on the technical side of my robot, instead of just focusing on the artistic stuff. I figured I would make this video just in case anyone watching was interested in making something similar, or you just wanted to know how everything works. Now, I don't have any kind of formal education in any of this stuff, like coding or electronics or anything like that, so I might not do stuff by the book, but hey, it works for me for the most part, and I think it might help someone. Alright, so let's get the tour started. I recently made a few changes to my robot to address some issues and tidy things up. I made this little case to house all the electronics for the robot, so now my wires are managed for the most part and everything looks pretty neat. I felt inspired by BMO from Adventure Time, and I printed and colored these little graphics that I glued to the case. Here you've got a heart with a medal for courage and a diploma. It's a pretty cute little reference, and I really love Adventure Time, so I think this turned out pretty great. So the box itself has two compartments. The first is full of PCBs and all the wiring, and the second compartment has the batteries. I designed it like this just for the sake of convenience, because this way you can keep the wires and PCBs tucked away and have easy access to the batteries if you want to take them out and charge them or put them back in. For the batteries, I have 5 AA nickel metal hydride rechargeable batteries. These are responsible for powering all the motors of the robot. They're wired in series and they put out around 6 volts. Honestly, if you're going to make your robot wireless, then it's pretty essential to buy some nice rechargeable batteries. Otherwise, you'll be buying a ton of disposable ones. I also have this little 9-volt battery here, and this plugs directly into the Arduino Uno if I want the robot to work wirelessly. Otherwise, if I'm coding and uploading stuff all the time to the Arduino, then I just have it plugged into the computer with a USB cable. Alright, so that's it for the batteries, and we can move on to the next compartment. And this is pretty much where the magic happens. First off, of course, we have the Arduino Uno. This is a pretty trusty little microcontroller, and it's responsible for controlling the whole robot. So the first thing that hooks up to the Arduino is a little IR receiver. This little guy picks up infrared signals sent from this remote control and then sends it to the Arduino. With this remote control, I'm able to go through all the different animations I have loaded onto the Arduino. Just click the corresponding button to the animation you want to play, and the robot does the movement. Really straightforward. I know more sophisticated toys and robots usually have some kind of Wi-Fi module to control things with your smartphone or your laptop or computer, but this setup is super simple and I really like it for its simplicity. Alright, so for the motors, I have quite a few different ones in my robot. I'll start with the stepper motors because there's only 2 of them, and they're responsible for letting the robot roll around on its wheels. And of course, with the bottom half of the robot being covered up by the dress, this creates the illusion that the robot is walking around. The steppers I use are the 28 BYJ 48 motors, and these are hooked up to the ULN 2003 stepper driver. I have 2 of them, and then those plug into the Arduino. The steppers and the drivers are really cheap, and they also work pretty well, so I'm quite happy with them. Next, we have the servo motors. I've got quite a few of them in here, and they're all responsible for the movement of the upper body. There's 9 servos in total, and they're all hooked up to one PCA 9685 PWM servo driver, which then of course hooks up to the Arduino. The first servo I have is also the biggest and toughest servo. It's a TD8120MG. It's a high torque servo, and it's got about 20 kilograms per centimeter of torque, and it's responsible for creating this side-to-side movement of the torso. Honestly, from all the humanoid robots I've seen so far, I would say most actually don't have any kind of actuator in the torso for this kind of movement. But I think this motion is really great for any kind of dancing animations, and it just makes all the different movements the robot does seem more lively and less stiff. Next, I have 3 of these MG995 servos, which are responsible for the left and the right shoulder and the neck turning from left to right. These servos are super cheap, and I've heard a lot of people really don't like them, but honestly, so far, outside of them being very bulky, they've worked pretty well for the price. And next, we have 3 MG90S servos. These are responsible for the upper arm movement and the tilt of the head. I really like these servos, but for whatever reason, they really don't like me. I bought 5 in total, and already 2 of them have burnt out on me. I'm not really sure what's wrong with them. It's a real shame because I really like the added torque and the extra stability that you get from the metal gears compared to the plastic SG90s. But for whatever reason, they've been breaking a lot compared to all the other servos I've used, so I'm not sure if I can really recommend them. And finally here we have 2 trusty SG90S servos, the smallest and lightest servos out of all of them, and they are used for the forearms. And that's pretty much it for all the electronics and the motors. Honestly, this entire robot is very accessible if you want to make something similar. All the parts together would probably be pretty inexpensive. The most expensive thing here would be the Arduino. So if you ever feel like trying to make something similar, I would give it a try. There's a few other things I want to mention, and then I'll go ahead and move on to the programming side of things. So one issue I had, which I found a pretty weird solution for, is servo backlash. Basically, since the gears in the servo gearbox have some play to them, and they're not completely rigid, one thing that happens is sometimes when the servo is trying to hold its position at a weird angle, it might start wobbling back and forth like this. One solution I found is to always have a bit of tension applied to the motor so it isn't able to start doing this wobbling thing. And the easiest way I found to apply that tension is this little spring contraption. The springs pull down on both sides of the torso, and the joint is pretty rigid while still being able to easily move when the motor wants it to. I don't know if this will be helpful for anybody else, but at least for me in this case, I was able to get rid of that jerky motion of this joint and get pretty smooth movement without this wobbling back and forth thing. One more thing I'll mention that might be interesting is that for the wheel setup, I of course have the two stepper motors, and attached to them are two big rubber wheels. And for the added support, I have these two caster wheels on the other end. This setup works pretty well. It gives the robot 4 points of contact with the ground, giving you quite a lot of stability. And the setup works pretty well. The robot turns fine, it goes back and forth and all that. So yeah, if you were thinking of building a robot that rolls around on wheels, I can recommend this setup with the caster wheels. Alright, now I'm going to talk about coding a little bit. And for me personally, this was probably the most difficult part of this project. I didn't know anything about writing code for the Arduino when I started this project, and the code I have now is pretty much just a combination of YouTube tutorials and forum posts, and somehow everything has seemingly worked out so far. So let's get into this, and I'll do my best to try and explain things for you. First, we have all the libraries that need to be included. The Servo library, the Stepper library, the Adafruit Servo driver library, and the IR remote library. Next is a couple lines of code about which pins on the Arduino are responsible for what. And then there's some code about stepper steps, PWM, and servo angles. Then we have the setup function, which essentially just executes some stuff and importantly sets the servos to go to the positions that give the robot its starting pose. Alright, so I'm not going to go through the whole loop, but I'll give this example here to show how it works, because the rest of the code is basically just variations of this one example. First, we start with this if statement, which essentially says that if the IR signal being received decodes to this particular code here, then the following functions get executed. And the functions themselves are just telling the servos to go to different angles and telling the steppers to take a certain amount of steps. And the end result is a sword swing or a dance or the robot waving its hand. I really wish I could explain the coding portion of this in better detail, but I'm kind of not the most educated on this stuff. But if you guys are struggling with coding as well, you can let me know, and if people are interested, I can make a more detailed tutorial for how the code works for my robot. Or you can also look into some animatronic animation software like Botango. There's also Blender plugins for animating your animatronics that could also be worth looking into. I just personally write the code the way I do because it works for me, even if it might not be the most sophisticated way of doing things. So that's pretty much it. One final thing I'll mention is that this entire project would probably not be possible without a 3D printer. The printer I use is an Anycubic i3 Mega S. I got it used about 3 years ago, and even with it being used, it's worked really well for me. I haven't really had any issues with it, and it's overall a really fantastic printer. Alright, so the next video will be a new character for my robot. I'm making Roxy from Five Nights at Freddy's, and she should be done in about a month or so, maybe even earlier if I'm not too lazy or preoccupied with other stuff. If you guys like the video, please like and comment and subscribe, do all that good stuff. Really appreciate it. And I appreciate you guys for watching, and I'll see you in the next video.